In the last lesson, we ran through generic terms such as artificial intelligence, machine learning, as well as deep learning. In this lesson, we are going to drill deep into the area of machine learning. So the following slides, you will see a few groups of machine learning techniques. These are not the actual techniques yet or the actual modeling algorithms. These are just groups. So the first that we are going to cover is supervised learning. So where supervised learning is concerned, we are trying to make a prediction. In other words, inferring a function or making a prediction from labeled training data. Labeled because we have past data where we have the result of the actions that we are going to take. One example is to identify potential credit card customers if you are a bank. So for example, if I were in charge of the credit card acquisition for a particular bank, I would first start with all the information about my existing customers and what kind of customers were more likely to take up credit card. One example could be people who earn a higher income. We may notice that people who earn a higher income, they are more likely to take up credit cards. Therefore, after we pull out the model or we build the model, we can, based on new customers' income, predict how likely they are to take up a credit card. And if the likelihood is high, that is where we will market a credit card to them. So what happens if their score or their model score is not high, meaning that they are not likely to take up a credit card? What do we do with them then? For those customers, we will market some other products. So the aim is to try to identify products that are relevant to each individual customer. So that is the case of supervised learning. Let's take a look at what the process looks like. It always starts with raw input data. So in the case of the credit card customers, or rather the problem statement of trying to identify people who are likely to take credit card, the raw data could be something such as their income. So we want to start with their income, and we put it through an algorithm. This algorithm we will cover in the next lesson. It could be a regression, it could be a decision tree, it could be a number of different techniques, but they all belong to the group of supervised learning. Thereafter, we build the model, we process it, and we finally get our output. Henceforth, whenever a new customer comes in and they provide their income, we pass it through the model and we get the same output. This means that we are henceforth able to predict how likely a new customer is to take up a credit card. In terms of a human intervention, we still need a human, meaning this supervisor that you see on my mouse. He will actually be the one that determines how to break up the data set into training and test and determine what is our desired output. In the case of identifying credit card customers, the desired output is that they actually apply for one. So that is the example of supervised learning for identifying credit card customers. In the next slide, we see a few different examples of supervised learning in action. It could be, for example, predicting the crime rate in a particular region based on variables such as where it is located or past crime rate. Next, we have things such as amount of fraud or probability of fraud, predicting house prices and how many will fail. On the right hand side, we've got a few other examples: fraud or no fraud, spam or no spam. So spam refers to whether we can identify whether an email that you receive is spam or not, whether a certain person's credit rating is good or bad, whether the risk is high or low, and whether it's sick or not. The difference or the two categories between the left and the right is that on the left hand side, we predict something that is a running number. So for example, house price, it can be $5, $10, $100, 50,000, 100,000, and so on. On the right side, it is categorical in nature, meaning there are only two options, whether it is fraud or no fraud, or it is spam or not spam. So those are the broad types of what we call labels. So this is what we are trying to predict. These labels are what we are trying to predict in the future, and these labels are what we are using to build our model. So to summarize, the key thing that you need to know about supervised learning is that we have some sort of past data that we can use where the label is available, meaning that in the past data that we use to, for example, predict house prices, we have the house price for all those transactions in the past. That's what it means. Next, let's move on to unsupervised learning. As the definition suggests, it's a type of self-organized learning that helps to find previously unknown patterns in datasets without pre-existing labels. Let's try to explain this using an example. So the example here is that we want to identify segments within wealth customers if I was a bank. And what do we mean by identifying segments? Here, we want to identify groups because we can offer them relevant privileges, such as, for example, air miles or luxury or spa. So, for one segment of customers, such as the businessmen, air miles might be very relevant to them because they frequently travel and they may not be so keen or inclined to take up like a spa package. However, on the other hand, if I have another group of wealthy customers such as housewives, these housewives may not like the idea of air miles because they may not be traveling frequently, but what they appreciate is that if you give them like luxury spa visits or discounts on luxury goods. So by being able to identify groups of customers, we are able to offer more relevant privileges and engage them in a deeper manner. So before running this algorithm, wealthy customers are all just in one big group. There is no way for us to separate to say that because of certain factors you should belong into group A or group B. We need to find some way to identify customers that are similar. So that is where this unsupervised learning comes in. So in this example, before running the model, we do not pre-existing or there's no pre-existing label where we say that a certain customer is belongs to a certain group. Only after running the model can we say that, hey, person A belongs to the businessman group and person B belongs to the housewife group. In terms of the process, we can input raw data. We again use some form of interpretation as well as algorithm. And finally, we process and we get some sort of output. So using the example of identifying wealth segments, the kind of raw data that we use could be, for example, their occupation, whether they are employed, their income, or things such as where they stay or what kind of car they drive. All these can help us to group people together. And this interpretation refers to what kind of data we should be putting into our model. Important to note is that the output in this case is unknown. Before running this model, I wouldn't know whether a certain person is a housewife or an executive, and there is no training data set. So with the algorithm and using the processing, we get certain outputs. And henceforth, what happens is that whenever a new wealth customer signs up with the bank, we can use his data, run it through this model, and predict should he belong to the housewife group or should he belong to the businessman group. Here are some machine learning use cases that cover. Lastly, we come to the concept of reinforcement learning. The primary difference in the case of reinforcement learning is about how agents try to take actions in an environment in order to maximize some form of objective or reward. So for example, it could be AI learning how to play chess in the case of AlphaZero, or AI learning how to play a multiplayer game called Dota 2. The agent would be OpenAI. So at this stage, it is sufficient to just know that reinforcement learning is about trying to provide, or the computer trying to try different options to reach an objective. We will not go into detail about reinforcement learning at this stage. See you in the next video where we will find out what an AI engineer at Google does. Thank you.